What is the most likely product of this reaction? Well, what we have here is an aromatic ring. We have a moderate base. And then if we look on this aromatic ring, we have leaving groups. So under basic conditions, you can replace a leaving group on an aromatic ring only if it is electron deficient enough. And that's by a process of nucleophilic aromatic substitution. Now, in order to do so, you need to have an electron deficient ring. So either you need to have a nitro group, ortho or para to a leaving group, or you need to have a pyridine type system where you have a double bond nitrogen within the ring. Those are electron deficient enough, and that's what we have here. So it can do nucleophilic aromatic substitution. So we can do a nucleophilic aromatic substitution. Now, we have two leaving groups. We have a fluorine and we have a chlorine. Now, the fluorine is the better leaving group than the chlorine is. But when you're dealing with a nucleophilic aromatic substitution, it's important to know that the electron withdrawing group has to be located in a certain position. In case of a nitro, it has to be ortho or para to it. In the case of these pyridine systems, the leaving group has to be located on either carbons 2, 4, or 6, because only in these systems are you able to put the negative charge onto the nitrogen, stabilizing that, making it possible. And so in this case, the chlorine is going to be the leaving group that's replaced. And so when we look at these, this molecule, so we need to put this group next to, on the carbon adjacent to the nitrogen. So that rules out A. C is a possibility. B went para opposite the nitrogen, but there's not a leaving group there. So that eliminates that one. D went right next to the nitrogen, but there's not a leaving group there either. So C is the correct answer.